Hello guys, today we're going to start converting this Siku Control 32 John Deere 6920S to work with my radio system so that I can use it with the same controllers as the rest of my tractors. So what I'm going to do today is modify these two servos so that I can control them with the Arduino. So all these parts here are the bits that I'm probably going to have a use for. These parts here are probably not going to be much use to me. Don't need an infrared controller, we don't need a channel switch, we don't need the control board, we don't need the light pipe, and this little board was for isolating the controller from the body of the tractor. We might need that later on, so we'll just have to see. You've probably seen in a different video I tried to figure out how to control one of these Siku servos, but I wasn't able to figure out how to control it. You can see it has 4 wires here, so it's probably some sort of serial interface, but I wasn't able to figure that out. So what I'm going to do instead is remove the control board and connect directly to the potentiometer and the motor, bring my 5 wires out, put the motor to a motor driver, another TB6612FNG, and hook the potentiometer up to an analog pin on the Arduino. That way we can read the voltage and know what angle we're at. So I'm going to do that for both servos. To get the servo apart, all you have to do is just pry the back off the servo. It's pretty simple, no screws. They're just a little bit tight, that's all. So just pull them off. There's a little bit of tape on this one. This one just goes out to the side. But they're identical servos inside. Same control board, same potentiometer. We just need to be careful desoldering them, and it should be pretty simple. Okay, we start with the steering servo. I suppose first thing to do, pull up the PCB and remove the motor wires. So that's the first part done. Now we just need to get the potentiometer off. This could be easier said than done. The soldering is quite rough on this PCB. It was probably pretty cheap manufacturing facility that built this. I don't know if it was made in Germany or made in China. No, I'll have to do this off camera, it's a little bit too tricky. Well, here's the potentiometer off. I know I said I'd try and save this little PCB if I could, but I ended up moving the capacitor on the back here. I think that capacitor there. But anyway, it doesn't really matter that much. I still have the 2 servos in the fent, so if someone figures out how to control one of these before then, I'll do it with the fent. I'll figure out how to control it with the fent first. So this should just pop back in there, I think. That is our servo the way we want it. This top piece holds the potentiometer in place. So now we just need to add our 5 wires and close it up. Okay, here's the servo wired up. That only took maybe 20 minutes, something like that, to wire it up. Nothing too major. I have 2 white wires for the motor, a red wire for the positive, blue wire for ground, and green wire for the signal from the potentiometer. And here's the signal at the minute. We've 3 volts output. So if I move the motor, we should see the voltage change. You can see the mark on the servo there. So we've gone up to 4 volts there. Switch the wires. Now we can go back. And then the half a volt. That's how every servo works. A hobby servo, a Siku servo, it's all the same. All that happens is you move the motor moves the gear, and it also moves the potentiometer, and you read the voltage from the potentiometer. The little control board that's inside the servo monitors this voltage, and when you tell it to go to an angle, it associates that angle with a particular voltage. The motor moves until you get to that voltage, and that's all there is to it. That's how pretty much every single servo works. If for some reason you wanted to convert your Siku Control 32 model to use standard RC receivers and controllers, all you have to do is remove this board and replace it with an equivalent board from a cheap hobby servo, and as long as it was small enough to fit in there, all you have to do is wire up your potentiometer and your motor to the other board, and you should be able to convert this to just a normal hobby servo. You can do the same thing with the drive motor. So all you have to do is look up how to convert a servo to continuous rotation. All you have to do is put two equally sized resistors across the pins that used to be for the potentiometer on your hobby servo board. Connect your motor to the servo motor pins from the servo board that you have, and then you should have continuous rotation. When you push the joystick forward, you should get some sort of speed control, and the reason for that is you've fixed the potentiometer so the voltage is always going to be dead center in the middle. But so as you push the joystick forward, the servo board tries to move the output of the servo to say 180 degrees, but the two fixed resistors are never going to change, so all you end up doing is speeding up this motor. Okay, well, I have the Arduino and the TB6612 FNG motor driver set up here just to demonstrate the servo. So I have a simple program set up on the Arduino here that's just going to move the servo to 90 degrees. You can see on the right here the little mark. So when I give it power, it should move to the center. So there you go, it's moved to the center now. And if I move it again off center, you're not supposed to push servos like that. You're not meant to push them from the lever arm. So try and minimize that. You risk damaging the gearbox doing that. But anyway, I've moved it over to the left. I'll give it a bit of power now, and you can see that it's moved back to the center. That is basically all that's going to happen inside the tractor as well. Okay, I have the lifting arm servo wired up now as well, and I have this on just as a kind of a test load. So you can see it's fully down now. So when I put the power on, see, it lifts it up and it holds it there. So what happens is when we put the power on, our servo is very far away. So we take our measurement, we convert it to 180 degrees, and we're trying to get to 90 degrees. So we'll say we have 0, so there's a difference of 90 degrees between where we want to be and where we are. So we start off with a speed, a pulse width modulation, going to our motor driver here of 100 out of 255 points. So that's what our PWM is set to. Then as the servo gets up, gets closer, gets to within 5 degrees of the position we want, it slows down to 25 out of 255. That's our pulse width modulation width. So it slows down and allows it to hold its position. If it was able to get to 90, the pulse width modulation would stop, but that would result in our arm falling back down. So it always sits around about that 25 out of 255 mark. So that's why you can hear the servo is under a little bit of pressure. So if I lift it up, now we're at the 0 point because there's no load. But we have to keep the servo slightly active to hold the position. But we don't want it too active or it'll start to jitter. It'll jump up and down and you'll see the servo jumping around then. Well, I think I'll leave it there for this video. We have the two servos pretty much working. I have a pretty good idea of how the code has to be written for the Arduino control. So next thing I have to do is try and fit two motor drivers in here, an Arduino which is in here, a battery. I think I'll have to modify the battery slightly, just take this top piece and fold it over to squeeze it in there, and that should be pretty much it. I don't think it's going to be too hard to wire. It should be pretty straightforward. So if you like that video, make sure and hit the like button and share the video. And if you have any comments or any suggestions, post them below or in the forum. And that's pretty much everything. So thanks very much for watching.